All right, let's go ahead and get started. Welcome to our webinar today. My name is Justin D'Souza. I'm a quantitative specialist here at Statistics Solutions. During today's webinar, we will be covering SPSS data cleaning and management. So I'm going to go through the entire presentation, and I will answer questions specific to the topic today at the end of the webinar. So you can type your questions into the chat box or the question and answer box. My colleague Isades will also be answering questions during the webinar, more pertaining to the what the company provides. She will provide hyperlinks that you can go to self-schedule if you have any questions. So let's dive into today's topic. So I'll start out with a brief overview of the services that our company Statistics Solutions provides. We'll then discuss SPSS data cleaning, and I will be going through SPSS and providing an example. We'll conclude with a summary and a question and answer session at the end of the session. Statistics Solutions provides assistance with every part of the dissertation process. So the way our company works is we have both methodologists and literature review specialists. We have methodologists that are specialized for both quantitative and qualitative studies. So we assist with topic development, prospectus and concept papers, the proposal chapters, which includes the introduction, literature review, and methodology. We help with IRB forms, data entry templates. We can host your survey for you on SurveyMonkey. We assist with both quantitative and qualitative results chapters, as well as the discussion chapter, PowerPoints for defense, and journal publications. So if you've hit a roadblock during your dissertation or your thesis, please give us a call at 727-442-4290 for a free consultation. On this slide, I have a copy of 2 web links that will direct you to our previous webinars and upcoming webinars that we will be conducting in the future. Sadie's will be providing some links in the webinar chat box if you have any questions about scheduling a consult, or I should mention that we will be sending everyone a copy of this presentation as well as a copy of the recording of today's webinar. All right, so diving into the topic today, what do you do when you first receive your spreadsheet? Maybe you have archival data, maybe you're using SurveyMonkey or Qualtrics, or maybe you're collecting data by hand. Once you've completed that data collection step, what do you need to do next? Well, if you're using SPSS, there are several efficient functions that you can use to clean your data set and prepare it for data management so you can address your research questions. First thing you'll want to do is add an ID variable so everyone in your study can quickly be identified with a number. So many studies now and many colleges today require that you de-identify your data, meaning that you don't use names or email addresses or phone numbers to identify your participants. So this is where you can assign everybody a confidential number, or you can just number everybody from 1 to 100, or however many participants you have. So I will show you how to quickly do that. The purposes of that is so you can keep a track of all your participants. If you're removing people, you can quickly identify who those people were based on the number that you have given them. The next thing you want to do is name all of your variables of interest that are tied to your research questions or maybe descriptive statistics that you want to examine. And if you're using previously validated surveys like the job satisfaction survey or the multi-factor leadership questionnaire, you can use a quick autofill command in Excel to name all your variables. third step, and this is a recurring step, is you want to save your spreadsheet often. After making any major adjustment, I'll even say minor adjustments, you want to save a new copy of your spreadsheet so you have a running record of all the adjustments that you're making. Maybe you remove people due to outliers or missing responses. Maybe you're recoding variables from string to numeric, or you're reverse coding items. I would recommend saving after every one of those adjustments. So let's dive into an example here. We do have a survey here that was measuring 3 components. So we have 3 different surveys within this one spreadsheet. So this is what data view looks like in SPSS, where you can see rows are individual participants, and this was extracted from SurveyMonkey. So this is directly from SurveyMonkey and how it looks when they send you the data. We have rows as participants and we have columns as variables. And in this spreadsheet, we had 3 different variables we're measuring. We have 7 items to measure leadership effectiveness. We have 5 items or 6 items to measure job satisfaction, and 5 items to measure organizational performance. So the purpose of this study was, how does leadership effectiveness and job satisfaction predict organizational performance? The first thing you want to do is kind of just take a look at the overall responses. We have missing cases, and yes, we can see immediately there are participants that missed almost the entire questionnaire. So they answered the first one and then opted out. We have participants who are missing responses in the middle. So they answered a heavy majority, but just missed an item here and there. We have data in both numeric and string format. So numeric means numbers, essentially, where the Likert scale can go from 1 to 5, strongly agree to strongly disagree. So we have numeric format, but we also have string format for this final questionnaire. So we'll want to look at that. So those are some general housekeeping notes that we need to keep in mind when we want to clean the data. Missing responses, we have numeric data, we have string data. We'll move forward from there, okay? So the first thing you want to do is create an ID column. So typically I create that as the first column. I'm going to right click right here in data view, insert variable, and we have 100, about 100 participants, looks like 91 exactly. So I'm going to go into Excel and create an autofill from 1 to 91. So you just start the list, and then you drag down to 91. Unfortunately, there's not a quick way of doing that in SPSS, so I use Excel. 1 to 91, very good. And we'll call that ID and very years of service. Just one question. The first 7 items are leadership effectiveness. So I'll come in here into Excel. Let's call it leader effectiveness 1, leader effectiveness 2, then drag that down to 7. Second part was job satisfaction. We have 6 items here. And the final component is organizational performance. This one has 5 items. Okay, so I'll split the screen here so I can just copy and paste this. So the 7 items here are going to go there. Job satisfaction, 6 items. Organizational performance, 5 items. Okay, so we've done from our PowerPoint presentation, we've done the first two steps here. We now want to save, okay? Go ahead and save the spreadsheet and be specific with what we did for this step. Okay, so we have sample data, ID added, and variables named, and put the date that you're working on it. All right, so step one done. The next step is recoding Likert scale items into numeric form. So where we see strongly agree, strongly disagree, we want to change those to numbers. We also want to identify if any items need to be reverse scored. So maybe you have a question that is negatively phrased. You want to flip the Likert scale when that happens. And typically when you look at scoring instructions for a survey that you found online, they will indicate if any items need to be reverse scored. Okay, so just to reiterate, we are now going to recode from Likert string or string to Likert. So we have all of these in Word format, right? So we want to transform it. I'm going to go to transform, recode into same variables. And I'm going to move all the organizational performance items to this right box. Then I'm going to click old and new values. So a strongly disagree is a 1. So I put strongly disagree here. 1 is our new value. Then disagree will be a 2. Neither agree or disagree is a 3. 3 is a 4. And strongly agree is a 5. So I'm going into the spreadsheet and I'm copying and pasting it right here because there could be spaces before or after. So maybe if there's the slightest discrepancy where you have a space before or maybe a space after, this command is not going to work cleanly. So I would recommend going into your spreadsheet, copy, strongly agree, put it in this box, 5, and add the variable. So then we can click paste. I'm going to click paste here. You can click OK, but paste presents syntax. So syntax is a way to keep a running record of all the analyses and data cleaning steps that you are performing. This is very useful if you share your spreadsheet with someone else and you want them to replicate the same procedures that you did. So syntax is the code right here. This is the code for recoding string to numeric. So if I highlight this code and click this green arrow, you'll see it's going to change to numbers now. So I like to use the paste option whenever doing a command, just in case for myself, if I want to see what steps I did, I can look at the syntax file. Or if I'm sharing it with a colleague or a friend, they can see the sequential steps I took to clean the data. Okay, so now we have organizational performance is numeric. You'll see the symbol at the top. SPSS still thinks that this is a string variable, so we need to change that manually. In data view, you can see it still says string. I want it to say numeric right here. So numeric, you can copy that numeric and paste it for the remaining 4 options. And we'll keep it scale. Okay, so now we need to look at reverse coding items. Now I am familiar with the survey, so I know which items need to be reverse scored, but maybe you get a survey and you're not sure. A good way of determining that is to look at how the questions are phrased. So we need to make an overall score for job satisfaction. And we can see the Likert scale here goes from 1 is strongly disagree up to 5 is strongly agree. So we want higher scores to represent higher job satisfaction. So if we have a positively phrased item like I am paid fairly or overall I am satisfied with my job, we would want higher scores to be more indicative of higher job satisfaction. But if there's a negatively phrased item, my job responsibilities are not clear, or I am not satisfied with my job security, we would want a 5 to be strongly disagree. So they disagree with that statement, meaning that they have higher job satisfaction. So we need to flip the Likert scale on these two items because they are negatively phrased. To do this, we use a very similar command as we just did, but we're going to use recode into different variables as opposed to same variables. So I need to put in job satisfaction 1 and job satisfaction 4. And when you do it into a different variable, we have to provide a new name for this variable. So I'll call it job satisfaction 1 reverse. And then job satisfaction 4 reverse. And all reverse coding is flipping the Likert scale. So a 1 now becomes a 5, 2 becomes a 4, 3 stays the same, 4 becomes a 2, and a 5 becomes a 1. So you can see it goes up sequentially and down sequentially in perfect order. That is what we're looking for. So I can click paste, and now I have the syntax for that reverse coding step. So you can add comments in syntax. If you use an asterisk like this, you can say this first command was changing string to numeric, period. And then this one is reverse coding negatively phrased items. Okay, so we need to run this code here. Click the green arrow, and you'll see at the bottom of the spreadsheet, we now have 2 new variables that are reverse scored. What we need to do is put these in the correct order of the survey. We have job satisfaction 1 and 4. We want to take the old ones and move them to the bottom. So job satisfaction 1 and 4, not reverse, are going to come to the bottom right here. Okay, so we have 1 through 6 with the reverse items, 1 through 4, 1 and 4, the originals. We're not going to use them. We could delete them altogether, but I'd like to keep them in the spreadsheet just so we can keep a track of the original variables. Okay, so those are the next steps. We need to save again. So in this step, first thing we recoded, so recoding to numeric and reverse scoring. All right, now we need to deal with missing responses. So there are many ways to handle missing data. If you're way above your sample size requirement, in which you probably need to do a power analysis in your methodology chapter, if you find that you're way above that minimum sample size, then you can consider deleting any missing values because that's not going to affect your results too much. But there are many ways to handle missing data. If you're below that sample size requirement, you can use multiple imputation to replace or predict missing responses. You can also use mean or median imputation, in which you replace a missing value with the average of that variable. So I'll show you imputation. Multiple imputation is kind of a complex procedure. There are a lot of YouTube videos on this process. I would recommend taking a look at that. In my experience, it's rarely used unless you have archival data that's missing a ton of data. You might need to use multiple imputations. But in our example here, we are not missing a lot of data. We have participants that just failed to respond to the full questionnaire, so they come out altogether. But these people who missed a response here and there, we can replace with the average, okay? So a quick way to find the missing responses is to take any column, right-click, and sort in ascending order. That is going to uncover all of the missing cases at the top of the spreadsheet. Okay, so these 5 people need to come out. And I'll go ahead and save again. So now we have 86 people. I'll say remove full missing responses. N equals 86. 5 full missing responses. Being more descriptive is better. So when you get to your results chapter, you can say, I started out with 91 cases. We removed 5 for not responding to any portion of the survey after consenting, resulting in a final sample size of 86 cases. Now we can deal with these cases in the middle that are missing. And to do this, I'm going to go to transform, replace missing values. And I'm going to choose everything. Put it in this right box. And you'll see series mean is the default procedure used, which just means for any missing value, for instance, this value right here, to find a missing response to replace it, SPSS is going to take an average of this column, and that missing value will be replaced with average. Okay, so we can click paste again. So paste will give us syntax. And here's the code for that. Replace missing values with average. So you can highlight this code, click the green arrow. Now when we go back in, you'll see the same variables listed twice. We have leadership effectiveness 1, leadership effectiveness 1 underscore 1. So wherever there's an underscore 1, SPSS has created a new variable and replaced the missing values with the average. So as we take a look at this, we should have no missing data anymore. Okay, everything should be filled, which is what we want. And it looks good. Okay, so we can now, what I want to do is change the labels right here. I want to know specifically what these questions ask. I can just copy and paste right here the old questions and put it right here. And then we have the reverse coded items right there. Now I can delete the old items and just retain the replaced missing value items, okay? So I'm going to clear all of these and I'm going to save. Replace missing values with average. The next step is following the scoring instructions from the survey that you're using. So I would highly recommend using a previously validated survey. This is kind of a different topic altogether, kind of a methodology advice, but You want to avoid creating your own instrument because it creates hurdles in which you have to pilot test it. You have to prove that it's valid. It has construct validity and reliability. That just adds months, if not years, to the process. So I would say look for a survey that is previously validated, and that will save you time. And there will also be scoring instructions that you can follow to score your survey. Okay, so typically a mean or a sum is used on the individual survey items to make the overall constructs. Once you've done that, you want to account for extreme values or outliers. You want to remove extremely high scores or extremely low scores so they do not skew your data set. I'll show you how to do that. And then you want to test for reliability with Cronbach's alpha. Okay. So first, we will create composite scores. We have 3 different instruments: leadership effectiveness, job satisfaction, organizational performance. The scoring instructions for all 3 of these are actually the same. You take an average of all the items comprising the instrument. I'm going to go to transform and compute variable. We need to give the construct or composite score a name. So I'll call it leader effectiveness overall. Then you put the sub command, which in this case is mean. We're going to take an average of the 7 items. And you can click each one, put a comma, click the next one, put a comma, click the next one. But a quick way to do it, as long as it's in order, is just put the first one, write the word 2, click the last one. This is going to take an average of items 1 through 7. Click paste, and I'll do the other 2. Job satisfaction. One to 6, paste, and organizational performance. 1 to 5, and paste. Now we have syntax for the 3 composite scores. I'll put a comment here, creating composite scores. Run this code. And you'll see in the spreadsheet now, at the very end, we have 3 new variables. So everybody in the spreadsheet now has a leader effectiveness score, job satisfaction, and organizational performance. Okay, the next thing we want to do is check for outliers. To do this, I will go to Analyze, Descriptive Statistics, and Descriptives. I'm going to put in the 3 composite scores I just created in the right box, and I'm going to check mark this box here, Save Standardized Values as Variables. Click OK. This is going to standardize each of your scores around a normal distribution. So it's creating z-scores. And according to this citation here by Tabachnik and Vidal, they say to remove outliers that exceed positive or negative 3.29 standard deviations from the mean. So these are z-scores now, and we're looking for values that go above 3.29 or below negative 3.29. We can quickly identify that by sorting these columns in ascending and descending order. So if I do descending first, we can see this is the highest z-score. 2.79 is less than 3.29. So that is not an extreme high value. We don't need to remove that. Then we do sort in ascending order, and we have negative scores. Negative 0.97 is not close to negative 3.29, so this is not an outlier. We have no outliers for leader effectiveness. Then we check job satisfaction the same way. Sort ascending, no outliers. Sort descending, no outliers. Organizational performance, no outliers in the low direction or the high direction. We don't need to take out outliers. This is the method I've used for years of removing for outliers. There are other ways, like looking at box plots, but I think that's more subjective. I'd rather use a distinct cutoff for removing outliers versus kind of subjectively interpreting if something's high or low. All right, the next step we need to do is check for reliability. So this is Cronbach's alpha. Cronbach alpha is telling you how consistent participants are in responding to your questionnaire. So looking at reliability or consistency, and generally you're hoping Cronbach alpha is about 0.7 and above. Which means if someone was saying, I strongly agree for an item on the survey, they were consistent and they were saying, I agree on the other items, proving that they were reading the questionnaire properly and interpreting the questions appropriately. To check for Cronbach alpha, we will click on Analyze, Scale, Reliability Analysis, and you just put in all the items that are part of the survey questionnaire. So we have leader effectiveness, put that in the right box, we give it a name, and we click paste, and you can click OK there. So if we just click OK, it's going to present Cronbach alpha, which in this case is 0.965. That is excellent reliability. Anything above a 0.7 is acceptable. Okay, so let me show you a good indication of when you need to reverse code. So remember I reverse coded 1 and 4 on job satisfaction. Say I didn't catch that step and I retained the original 2 items. So if I do a Cronbach alpha test on that, 1 through 6, taking out the reverse coded items, putting original 2 in, or this is job satisfaction. I click OK, we can see what is going on here. We have a negative Cronbach alpha. So this is very good evidence that you probably need to reverse code items because people are not responding consistently. And we pinpointed the reason for that is because of the wording of the items. We have positively phrased items and we have negatively phrased items. So that's why when you double check it and you take out the original non-reverse coded items and put in those 2 reverse coded items, that Cronbach alpha fixes immediately. So that is the difference it makes by making sure whether you need to reverse code or not. Okay, so 0.91, that's also excellent. And we have organizational performance. Paste that one. And 5 items. Okay, so organizational performance, also 0.956, excellent reliability. So we can trust that participants were consistent in responding to the survey questionnaire. It's really good. So now we'll go ahead and save this again. So created composite scores, removed for outliers, run back alpha. At that point, your spreadsheet is finalized. It's ready for analysis. You have a final sample size. Everybody has responded to the survey questionnaire. We've created composite scores. So next, you want to, in the order of what a results chapter is, you want to discuss the data collection steps briefly. So what steps did you use? Did you use SurveyMonkey or Qualtrics? You want to discuss removing for non-responses, missing data, outliers. How did you obtain your final sample size? Then typically you dive into descriptive statistics on your demographics. So what is the distribution of gender, age, ethnicity, education level, things like that. You want to use means and standard deviations for your variables of interest, which is, in our example here, these three variables. So that's really easy. You just go to Analyze, Descriptives, and click OK. So these are descriptive statistics on the variables of interest, min, max, mean, standard deviation, and the sample size. And then based on your research questions, maybe you've proposed to use a linear regression or correlations or an ANOVA or MANOVA. You have to test for statistical assumptions before running that test. So typically you check for normality, homoscedasticity, homogeneity and variance, multilinearity, things like that. So you want to verify those assumptions and then address your research questions with the inferential analysis. Okay. That concludes our webinar for today. Thanks for joining us. I'm now going to do a question and answer session. So if you have any questions, you can type those into the chat box or the question and answer box. I just want to reiterate that our company, Statistics Solutions, provides assistance with every part of dissertation. So if you've hit a roadblock, please give us a call at 727-442-4290. You can also email us at info@statisticssolutions.com. All right, do we have any questions? Yep, looks like we have a question. Will this recording be available to be downloaded afterwards? We will be sending everyone a copy of the recording. Yep. A question from Tina. Can you show how to test for assumptions? Yeah, I can in SPSS. The thing is, it's very dependent on what analyses you're running. The assumptions are different for different analyses, but the most common assumption to check is normality. And unfortunately, there are 5 different ways to prove that. You can look at it visually with a histogram. You can use tests of significance. I'll show you a few of the different ways. So say we're doing Pearson correlations and we're trying to see the association between leader effectiveness, job satisfaction, organizational performance. Before we run a Pearson correlation, we need to make sure that these variables follow a normal distribution. So I'll go to Analyze and Descriptive Statistics and Frequencies. And the first thing you can do is create a histogram. Okay, so a histogram like this, and we'll click Continue and OK. This is a good visual to show how does the data look, and we can see leader effectiveness. We like to see a normal distribution peak around the middle and level off around the tails. Clearly, we do not have that with this variable, leader effectiveness. It's skewed to the right. It levels off towards the right. Likewise, with job satisfaction, looks a little bit better, but definitely more of the data is clustered around the lower scores. Organizational performance is the opposite in a way. It's skewed to the left. More of the data is clustered towards the right. Okay. So this is a way of visually looking at it. You can also do Shapiro-Wilk tests and Kruskal or Shapiro-Wilk and Kolmogorov-Smirnov tests. So if you go to Analyze Descriptive Statistics, Explore right here, put in those 3 variables of interest into the dependent list, and we'll go to plots. And where did that window come up? I think it's on my other monitor. Find it. Where'd it go? Oh, there it is. Okay. So after hitting plots, this is what comes up, and we'll check mark this box. Very important, normality plots with tests. Click continue and OK. We want to scroll down a little bit, and we want to look at these results. So there are 2 tests for normality. We have a Kolmogorov-Smirnov test, and we have a Shapiro-Wilk test. These are 2 rare instances where statistical significance is not a good thing. You want to see non-significance, meaning you want a p-value greater than 0.05. So what these tests are doing is they're comparing your data for leader effectiveness, job satisfaction, performance. They're comparing that to a bell-shaped curve. And if you have a significant result, that means your data is significantly different than a bell-shaped curve, which is not what we want. So we want p-values greater than 0.05 for these tests, which is not what we have. These are all less than 0.05, meaning that these variables significantly deviate from a bell-shaped curve. Not ideal. So there are many ways to proceed from there. You can try transforming your data, which you can use log transformations or square root transformations. That takes a lot of guessing and checking. You can go to a non-parametric analysis instead. So remember, I mentioned Pearson correlations. Instead of running a Pearson correlation, we can run a Spearman correlation as a backup. So a Spearman correlation is a non-parametric test and is not as strict on having a normal distribution. So you go to Analyze, Correlate, and Bivariate. Put all of these variables in. You can see Pearson is check marked on default, but you would also want to do a Spearman as a backup. We'll click OK. So this first box is looking at Pearson correlations, which do require a normal distribution. The second box are the Spearman row correlations. These are not as strict on parametric assumptions like normality. Okay, so again, you have to look at the specific test that you're running. Every test has different assumptions. I would say normality is one of those that kind of carries over to every test, almost every parametric test. So it's a good one to check. All right, let's see if we have any other questions. All right, so we have a question about process. The process, if using process analysis, are you required to conduct assumption testing or moderation mediation analysis? What would be the equivalent regression analysis in SPSS if using process? I do not have the process macro on my SPSS, but it is treated just like doing a regression. So you do want to verify that the assumptions are met for each path of your model, like linearity, normality with a QQ plot or a PP scatter plot, homoscedasticity. I think you would have to do those independently. You can't use it in the process macro. You would have to go to the regression menu and check for all those assumptions. So normality right here under plots. you would do the specific path that you're doing for mediation or moderation, and you would have to verify those assumptions separately from process. What is the best way to learn SPSS with examples of data sets to practice on? It's a great question. I would say I would look at Palant. I'll put the reference in the chat box. Okay, just give me one moment. Let's go all the way to the bottom here and survival manual, SPSS survival manual. I'm putting that in the chat box for everyone. So that's a good book that walks through all of the major analyses in SPSS, and I believe they provide sample spreadsheets to go through. Okay. With data cleaning, what YouTube or resources do you recommend to gain a better understanding of how to determine what missing data items to remove? Well, you're going to receive a recording of this. So if I went a little fast, you can rewind and go back through that section. But going through in YouTube, if there's anything, there is a doctor that I have used for years that he explains concepts in SPSS very straightforward. So let me that. So it's Todd Grande is his name. I'll put that in the chat box as well. Dr. Todd Grande. I'm not sure if he covers cleaning, but he does discuss different components that I covered today. They're just in separate videos. It's not like one video for data cleaning. He talks about preparing the data in Excel so you can import it. He talks about transformations, which I touched on as a way to fix normality. You can use log transformations. Checking for outliers, he might do it a different way than I do by using z-scores. He talked about reverse coding. So a lot of the same things. So I think that's a good resource to check out. All right, do we have any other questions? Thanks for joining us. Come join us for the future webinars as well. Let me keep that PowerPoint up. So we do have on the presentation everybody will be receiving, we do have a list of the upcoming webinars. Okay, so right here, we can see upcoming, this is the one we did today. Next Tuesday, I will be covering this one. Selecting statistical analyses made simple. So we'll discuss research questions and level of measurement for variables and how do you select the ideal for your research question. Then we will be touching on chapter 1 and chapter 3, the introduction and methodology chapters. Come join us for a future webinar. Thanks for joining us, Tina. You're welcome, Abdul. Thanks for joining. Do we have any other questions about today's topic? Any other questions? All right. Thanks for joining, Nicola. I'm going to go ahead and put Janine's self-schedule link in the chat box. That is a a hyperlink that will take you to schedule a free consultation with Janine. So if you have any questions, you can use that link and you can discuss your topic and where you are in the process, and Janine will guide you and provide a quote for the assistance we can provide. So that's in the chat box as well. All right, do we have any other questions? We have a question from Mr. Mustafa. Will you provide a certificate? I'm not sure exactly what you're referring to, but we will be sharing the webinar with everyone. You will receive a recording. Thank you, Tina. I appreciate that. I do see we have a question. Someone raised their hand. You'll have to type the question into the chat box if you have any specific questions or concerns. Hey, Dorothy, good to see you that you joined us today. Hope the webinar was helpful. All right, I'll stay on for a couple more minutes if we have any final questions. Any final questions about data cleaning, SPSS? All right, well, I'll go ahead and wrap it up for today. Thank you for joining, everyone. We have a question from Nicola from Australia. What day of the week is it where you are right now? It's still Thursday, early evening. It's about 6:30 Eastern time in the US right on Thursday. Yep. And we are very flexible if you do live in a different time zone. We have colleagues that work at different hours of the day, so we would be able to accommodate you. Absolutely. All right, thanks for joining, everyone. We do have some final questions coming in, actually. So at what stage of the PhD program seeking help from statistics solutions should take place? So it's any part. I see Isades is responding to this question right now, but it's really any part of the PhD process. Okay, so no matter if you're at topic development or you're trying to figure out your research questions, you need a theoretical framework. If you're at the methodology or literature review, we help with every part of the dissertation process. All right. Well, thank you for joining us, everyone. Have a great evening and come join us for the future webinars. Take care.